Hello everyone, and welcome back to another episode of the Internet Computer Developer Journey. In today's episode 2.2, Advanced Canister Calls, we're going to be exploring the other types of canister calls beyond what we discussed in episode 1.3, creating our first app. In that episode, we talked about the difference between update calls and query calls. And in today's episode, we're going to revisit the definitions of update calls and query calls, but we're also going to talk about some advanced canister calls such as composite queries and certified variables. So to get started, first let's define the different types of canister calls to make sure we understand how they differ from one another. So recall that query calls are executed on a single node within a subnet. Query calls do not alter the state of a canister, and they are executed synchronously and answered immediately once received. So they can be seen as a read-only operation. They aren't making any changes to the canister, they're simply querying information and returning it. Update calls, however, are able to alter the canister state. They are executed on all nodes of a subnet because the result of the update call must go through the subnet's consensus process. Update calls are submitted and answered asynchronously. So these are not read-only operations. They are going to alter the state of the canister, and they have to be agreed upon through consensus. So the result of a query call has to go through the subnet's consensus before it can be returned. Now let's talk about composite queries. So composite queries are query calls that can call other queries on the same subnet. They can only be invoked via ingress messages, either using VFX or through an agent such as the JavaScript agent or a browser front end. They cannot be called by other canisters. So they are a query call that can call another query within the same subnet. Certified variables are verifiable pieces of data that have an associated certificate that proves the data's authenticity. Certified variables are set using an update call and then read using a query call. So in order to create a certified variable, you first will use an update call to set that certified variable, and then once it's been set, it can be read afterwards using query calls. Then we also have atomic transactions. This refers to the execution of message handlers, which are done in isolation from one another. And we'll talk a little bit more about those further in this video. And lastly, we have inter-canister calls, which are pretty self-explanatory. They are used to make calls between different canisters. So to get a little bit more context on how these different types of canister calls fit with one another, we need a little bit of context on the ICP execution model. So at a very high level, a canister is used to expose methods. A method is a piece of code specifying a task that declares a sequence of arguments and their associated result types. Methods return a response to the caller, and query calls, update calls, and other canister calls are used to call those methods and then get a response. So when you use a query call, you are calling a canister's method and returning the response of that query call. When you use an update call, you are calling the method, you are intending to alter the canister state and then return the result of that altered state. A single method can consist of multiple message handlers. So a message handler is a piece of code that can change the canister state by taking a message, such as a request or a response, and then produces either a response or another request. Typically, message handlers are separated by the await keyword, which indicates that one message handler is to be executed at a single time, and to wait for that to finish executing before moving into executing the next message handler. And this is because message handlers are executed atomically or in isolation from one another. And so this is furthering that definition of atomic transactions. No two message handlers within the same canister can be running at the same time. When a message handler starts to be executed, it receives exclusive access to the canister's memory until it finishes execution. No two message handlers can execute at the same time, but two methods can execute at the same time. So it's important to understand the distinction between methods and message handlers. So a single method can have multiple message handlers, but only one message handler can be executed at once, but multiple methods can be executed at once. So that can be a little bit confusing, so it's important to understand that distinction. We also have a deep dive on the ICP Medium blog that goes in depth into the ICP execution model, and we highly recommend that you check that out if you want to get some more detail on how all of these different components play into the execution model. So query calls we have talked about in the previous tutorial when we created our first app. And just to summarize, they are only reading a canister's information. They aren't making any changes to the canister state, and they are read-only operations. They are returned faster than update calls since they don't need to go through the consensus process. And it is important that when you're designing your dApp, you notice where query calls can be used in places of functions that return queried informations, since they can be an effective way to improve application performance. If we take a look at this example query call, we are taking a look at a Motoko code snippet that is defining an echo function, and it queries the function's result and doesn't make any changes to the canister's state or the canister's data. So we can see that the actor called echo is defined, and it uses a public query function with a input argument of type text that is called phrase, and it returns a result of type text. And so then it just returns that variable of phrase. Then update calls. So remember that update calls are used to alter the state of a canister. Any changes that are made with an update call are persisted, so they are permanent changes. They are not temporary alterations to the canister. Update calls are submitted to all nodes on a subnet. And again, that is because update calls must go through consensus before the result of the update call can be returned. Update calls do have a higher level of security since 2/3 of the replicas in a subnet must agree on the result, but in return, they do take longer to process and therefore have a lower performance level than query calls do. So now let's take a look at an example of an update call. Update calls are not defined with a function modifier in Motoko code, such as query calls are. So in the query call example, we saw it was defined as public query function. Update calls do not have a modifier keyword, so that is important to note when writing your code, that if you want it to be a query function, you need to specify it with the query keyword. So if we take a look at this example Motoko code snippet, we can see that we have an actor called count characters that is defined, and then it is going to make an update call that counts the number of characters within the inputted string. Then it's going to update the canister state and return a true or false value if the number of characters is divisible by 2. Then moving on to certified variables. So we initially defined certified variables as a type of data that includes a certificate that can be used to verify the data's integrity. Since query calls do not go through consensus, their response can't be validated in the same way that the response of an update call can be validated. So in order to remedy this, certified variables can be used instead, since they enable queries to return an authenticated response that can be verified and trusted. Certified variables utilize chain key cryptography in order to generate digital signatures that can then be validated using a single permanent public key that belongs to the ICP network. This is a little bit different from traditional signatures since the private key never exists in one location. It is constantly distributed between many different nodes on the ICP network. A valid signature for the certified variable can only be generated when the majority of nodes storing the pieces of the private key cooperate in the cryptographic protocol. So using this method, an application can immediately validate all data that is covered by the certified variable without having to put trust in a particular node that they've received the query response from. And all of the certification happens at the canister level. A certified variable is set during an update call, and then it can be read in a future query call to return the certified variable's response. We will dive deeper into using and creating certified variables in a future tutorial, 3.3 certified variables. Moving on to composite queries, recall that we initially defined composite queries as a type of query that can be invoked via an ingress message, such as one created through DFX or generated by an agent such as the JavaScript agent. And these composite queries allow a canister to query a method of another canister using an ingress query. They can be used to query canisters on the same subnet. So for example, you may have a project where you are storing a database across several storage canisters, and then you have a single index canister that can determine which portions of the database are stored in which of the storage canisters. Composite queries can be used by the index canister to make queries to the database across those different canisters, since the index canister can make composite query calls to the other canisters. Without using composite queries, the client would first need to query the index canister to get information about the storage canister that they should call, and then they would need to make the call directly. So by using composite queries, the index canister is able to make those calls on behalf of the user and then return the intended response to the user without them needing to make several steps. It is important to note that composite queries are only supported in DFX versions 0.15.0 and newer. And lastly, we have inter-canister calls. So these inter-canister calls refer to the ability to make calls between different canisters. And we are going to jump into an example using inter-canister calls to better demonstrate how inter-canister calls work. So in this example, we're going to use a setup called the pub/sub example, or publisher subscriber. This is going to contain two canisters, a publisher's canister and a subscriber canister, where the subscriber canister is going to send an inter-canister call to the publisher canister that indicates it would like to subscribe to a topic, which in this example is going to be a key value pair of type text and nat. Then the publisher canister can publish information on that topic, and the subscriber canister will receive that published information. So to get started, we are going to first create a new project, and we're going to be cloning the DFINITY example repository because this is going to contain the tutorial's example code. This tutorial isn't going to follow the default DFX template that we have been using in the previous examples. So in this example, we are going to clone this example repository and then navigate into that project. So to do this, first we want to navigate into our working directory so we can see that currently I am in my developer journey counter tutorial directory from the previous tutorial of creating our counter example, which showcased how to use stable variables. So I'm just going to go into the directory right above this, the developer journey directory, and then make sure that I'm in that top level directory. And then I'm going to DFX start, clean background to make sure that DFX is already running. And then I'm going to git clone, and then I'm just going to copy and paste this URL to make sure that I get it correct. And this is the DFINITY examples repository. And this contains several repositories for different languages, including Motoko and Rust. And it also showcases examples for different workflows, such as hosting sample web pages or hosting web-based games. So this is a great repository if you want to use a boilerplate for developing a project, or if you want to get inspired and play around with a few different examples. And we will be using this examples repository in several of the future tutorials, so it is good to have cloned anyways. So then we are going to navigate into the examples. We're going to be using the Motoko folder, and then we're going to navigate into the pub subfolder. So then if we print the working directory, we should be in our developer journey if that is your working directory for your projects, and then the examples, Motoko, pub sub directory. And so then if we do an ls, and then I'm just going to do an la to see the full output of these files, we can see that we don't have a lot of working files in this example. We have primarily our dfx.json file, then we have our source directory. If we ls our source directory, we can see that we have one folder called pub and one folder called sub. And then if we ls pub, we can see that in that we just have a main.mo file. And then if we ls sub, we can see that we also just have a main.mo file in that as well. So we're going to start out with our publisher canister. So the code is already written and located in this main.mo file that is in the source/sub directory. But we're going to open this in Visual Studio Code, and we're going to take a closer look at this code. So if we navigate to Motoko, and then pub sub, source, pub, and then we're going to open that. Going to open this main.mo file. I'm going to close the file explorer so we can see everything. So to get started, we can see that we first import the Motoko base library package called list, and then we define an actor called publisher with this line here, actor publisher. Then we're going to create a new type called counter. And this stores a key value pair. So we're defining this type counter. It's going to have this key value pair of topic value, where topic is going to be of type text and value is of type nat. Then we're going to create another value, or then we're going to create another type called subscriber. And this is going to store a key value pair but in this case, it is a key value pair of type topic, or of name topic with type text, and then name callback. And it's going to store the result of the shared counter function. And so then if we look down here, we have define a function called publish. And so this stores another key value pair. This is going to use the key of topic with type text, and then it's going to use the value of callback, which refers to the inter-canister call that will be used to return the value of counter. And so it's going to refer to this type of counter, which is this other key value pair of key topic and value of value. Then we're going to define a stable variable known as subscribers. And so remember that stable variables are going to persist across upgrades. And then we're going to define a public function called subscribe, and that is going to allow the subscribers stable variable to be altered with using list.push. So this uses that imported Motoko library of list to create a list of the subscribers. Lastly, we're going to define the public function of publish. So this is going to publish that counter data type. So that refers to that data type we defined of this key value pair at the beginning of this code. And then for each subscriber in the list, if the subscriber has subscribed to the topic in the counter key value pair, then the subscriber will receive an inter-canister call defined by this callback, and it will receive that counter value. So what this means is that when a subscriber subscribes to a topic, it's going to be added to the list for subscribers. It's going to have this data type of subscriber where it will indicate which topic the subscriber has subscribed to. Then when information is published to that topic, that is stored in the counter type. If the subscriber is subscribed to that topic, it will receive an inter-canister call with that topic's new information. So then we need to take a look at the corresponding subscriber canister. So far we've only looked at the pub canister. So let's take a look at the subscribe canister. So first we're going to import the publisher canister so that we can make calls directly to the publisher canister. And then we're going to define our subscriber actor. And then we're going to define that same data type of counter where it is a key value store with the key of topic and type text with the value of value and of type nat. And then we are going to define a variable. So this isn't a stable variable, this is just a normal variable that will not persist across upgrades. And we are going to have it be of type nat, and we're going to initially have it be the value of 0. Then we're going to define a public init function, and so this is going to define a function that sends a call to the publisher canister, and that call is going to indicate that this canister wants to subscribe to a topic, and it will trigger the update count function. Then we're going to define that update count value, which is going to update the value associated with a topic. And then lastly, we're going to define a function that queries the value of count. So we can see that it is defined as using the query modifier, whereas the other functions are not. And so this is just going to return the count of that topic. So now that we've taken a look at these canisters and their code, we are going to deploy them and see how we can interact with them. So we're going to go back in our CLI window and we're going to use the dfx deploy command. We aren't going to use the network IC flag since we are just going to be deploying locally. And so we see that once those are deployed, we are first going to call the subscriber canister and subscribe to a topic called astronauts. So we're going to use the dfx canister call command. We want to call the sub canister, and we want to call the init function. So we want to call this public init function. And with this, we need to define a topic of type text, or we need to pass an argument of type text to satisfy this topic input. And so we want to use astronauts. And so to do this, we need to use a single quote, a parenthesis, and then a double quote, and then astronauts, and then close all of those. And the output for this is just going to return two empty parentheses. This is expected. And then we are going to then publish a value to be associated with the astronauts topic. So remember that the value data type is defined as type nat, so this has to be a numerical value. So to do this, we want to then call the pub canister with the dfx canister call pub. We want to call that canister's publish function. And then we're going to need to send it a record in the data store format that we've defined. So to do that, we're going to use a single quote, a parenthesis, the word record. Then we're going to use a curly bracket, and then we want to use topic in double quotes equals, and then more double quotes, astronauts, close those quotes, and then use a semicolon, and then we want to tell the value of that to equal 5. And we don't need to put quotes around 5 since it is a numerical value, it is not a text string. And then we can close the curly brackets, close the normal brackets, and close the initial single quote. And then that will also return the parentheses. Then if we DFX canister call, we call the subscriber canister, and then we can call the get count function. And so this is this final query function that is just going to return the count value from the publisher canister. So since our subscriber canister is subscribed to the astronauts topic, we want to get the count that is associated with this astronauts topic. And so that should return 5. And we can see that it returns 5 with data type of nat. So that will wrap up today's episode. If you like today's videos, be sure to like and subscribe to the DFINITY YouTube channel to stay up to date with when the next episode of the Internet Computer Developer Journey is released. If you got stuck anywhere today, or if you have any questions or want to connect with other developers, be sure to check out the ICP Developer Forum, Developer Discord server, or any of the other resources listed in the footer of the Developer Journey documentation, including upcoming hackathons, upcoming boot camps, and other resources such as working groups. We'll see everyone in the next video. Take care.